Hello, my name is Peter from EdukoMondo. A warm welcome to this lesson covering useful hints and tips to optimize the setup of your STEAM class. STEAM stands for science, technology, engineering, art, and math. This series of lessons has been made to help the very beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. We decided to make this series as there are very few Arduino courses available with the beginning STEAM teacher in mind. Unique to these lessons is that they are dubbed and subtitled in several languages using artificial intelligence. This helps to make these lessons to be available to an as wide as possible audience. The lessons do not require an internet connection and are available on high-capacity memory cards by EdukoMondo. You can even watch these videos on your Android phone while commuting to your school. In case you do have an internet connection, the lessons are available on YouTube. The ultimate purpose of this course is to help closing the digital gap and to kindle the scientific and technical interest of young people. This course is the first step to get to the next level and learn about robotics or climate technology. At the Explorer level, we teach the teachers how to work with a microcomputer and electronic components in a classroom environment. All of our projects are based on the Arduino microcontroller. This is one of the most commonly available and affordable microcontrollers with a large user and support base. Each lesson is built around a project that you can develop together with your class. The projects are based on starter kits. As you can see, starter kits are available in many different forms and brands. Luckily, they all contain more or less the same components. So even if you don't have the same starter kit as the one we are using during the course, you will still be able to follow along. For our series, we have mainly used the starter kit offered by Key Studio. The price quality is good, and it comes with these cardboard figures that make the project more attractive to the younger students. For some lessons, we have used other brands and even original Arduino hardware simply to show you that you have the choice. Because each classroom will be different in terms of number of students and infrastructure, we have taken a classroom with 30 students as our reference. A successful STEAM class is all about team collaboration. Ideally, you split your class in smaller groups of 3 students. This implies that you will need at least 10 starter kits and 10 computers. I say at least because it's good practice to have some spares. We recommend to have 12 starter kits and 12 computers available for a classroom with 30 students. Because the starter kits can be reused in different classes and over several years, the investment can be spread over several classes and many years. The components that will disappear or break the quickest are the jumper cables and the resistors. It is useful to keep a stash of extra cables and resistors. Once you start using servos, stepper motors, or other high-powered components, the USB power supply connected to the laptop will no longer be sufficient. You will need an additional 9-volt battery or power bank to supply sufficient energy to the components. You can also use a power adapter, but for security reasons we don't recommend this. We advise to use laptop computers, simply because they operate on batteries and will continue to work in case of a power interruption. These can be second-hand or refurbished models, as long as they run Windows 10 or 11. Unless you will use the computers for other purposes, the basic model will do for our projects. Next to the computer and the starter kit, we recommend some additional equipment to make your class more successful. The first is a multimeter. We consider this as a necessary tool for the teacher to check components and circuits. Fortunately, a good multimeter does not need to cost a lot. The one that is shown here was bought online for less than $25. Beware that the very cheap models can have a lower safety rating, so make sure that you buy a Category 2 model. The second is storage boxes. As the projects become increasingly complex, you will have to deal with more and more components. In order to keep track of the components, some large storage boxes with subcompartments will come in very handy. Here we show you some of the boxes we are using. Unfortunately, the boxes that you get with the starter kits are usually either in cardboard or they are far too small. The third useful item is a large soldering mat. Although we will not be soldering during our course, these mats allow your students to work in an orderly fashion and decrease the chances that they will drop and lose components. Once on the floor, small components are hard to find. These mats are specially made to handle small components. They contain boxes and spaces, and some of these spaces are even magnetic. In addition, they provide protection to the microcontroller. These mats can be obtained online and will cost around $20. To protect the microcontroller and the breadboard, we also recommend the use of a mounting plate. Some of the starter kits come with a mounting plate, others do not. Inevitably, students will drop microcontrollers. The more they are protected, the longer they will survive. You can obtain microcontroller mounting plates like this one, which is a great investment of around $15, and it will protect your microcontroller. The next category are the nice-to-have tools. The first one is a component tester. This is a very handy tool to quickly check the value of a whole range of components. It is also very useful to find the polarity of a component. With a price of around $30, it is not very expensive, but still. The second one is the oscilloscope. In its desktop form, it is quite an expensive tool costing well over $300 or $400. There are also portable versions that cost a lot less. You may find an oscilloscope to be a handy tool to show your class, for instance, waveforms, such as the pulse width modulation on the Arduino. Now that we have all our computers and starter kits, we can prepare our STEAM classroom. The first thing is to mount the microcontroller and breadboard on the protective project board. The Arduino is screwed to the board while the breadboard is glued to the board through an adhesive tape. The only time that you will need access to the internet is to install the Arduino IDE, or Integrated Development Environment. If you feel uncertain about installing the IDE, contact your local IT partner. They have the experience to install and test software that you download from the internet. Make sure that you download the latest stable version of the IDE. When recording this video in June 2023, this was the version 2.1.0. Follow the instructions during the installation of the IDE on the computer. Once the integrated development environment is installed, connect the Arduino to the laptop and check the environment. Select the right Arduino microcontroller. In our case, it will be the Arduino Uno Model R3. Select the right port. Check the serial monitor baud rate and also check some other serial monitor settings. Make sure you do this on all computers that you will be using, including the spare ones. To ensure that each lesson goes smoothly, prepare in advance for each lesson the following. What components are needed? Distribute only the components that are needed. Use the white or blackboard to explain circuits or diagrams, and if you have a projector, use it to show drawings and circuits. During your STEAM lesson, pay special attention to positive enforcement and allowing for errors. It will give the students the opportunity to think about the code, to discuss amongst each other what the error means and what the solution could be. In your class, don't be afraid to introduce deliberate mistakes so that the students learn to think critically and develop their problem-solving skills. Correct the error and run the program again. Each of our lessons end with giving you ideas for an assignment. The assignments at the end of the course are aimed to broaden the world of the students by asking to step outside of the STEAM topic that has been covered. For instance, you can have an assignment that includes arts topic, like music or painting. Or you can include other STEAM subjects, like biology or geography. The aim is also to motivate students to conduct research and continue to work together. You can start the following class by asking a group of students to step forward and deliver a presentation. It will build their confidence and lay the foundation for public speaking and expression. You are now ready to deliver your first lesson called Hello World. In this lesson, you will learn how to teach your students their first steps in the world of the Arduino, programming and electronics. Bye-bye for now, and I'm looking forward to see you in the next lesson.